wide color gamut has become a key benchmark in the modern TV industry, especially this year's highly anticipated SQD-Mini LED and RGB-Mini LED. Both technologies are now capable of delivering truly impressive color performance. But careful observers may notice that TVs equipped with SQD-Mini LED technology are labeled as 100% BT 2020 all scenes wide color gamut, while RGB models are simply 100% BT 2020 wide color gamut. What exactly does this all scenes label represent in real-world usage? What is the actual difference between all scenes and standard high color gamut? And which one should you choose? Today, let's find out. Before we dive deep into all scenes wide color gamut, let's first understand how these vibrant colors are actually produced. Take the screens we use every day, TVs, phones, or tablets. If you zoom in on a screen with your phone camera, you'll see that the image is actually composed of individual pixels. Each pixel consists of three colors: red, green, and blue. The three primary colors RGB. By adjusting the mixing ratio of these three primaries, we can generate almost any color imaginable. This allows us to see full color images on our display devices. In other words, the richness of colors that these three primaries can synthesize. Simply put, the variety of colors displayed depends on the color purity of red, green, and blue. The higher the purity, the more vibrant and diverse the colors become. To visualize this relationship more clearly, we typically use a 2D chromaticity diagram. The vertices of the triangle on this diagram represent the color coordinates of the three primaries. However, these coordinates are not fixed across every generation of TV. They shift based on color purity. The purer the primary colors, the wider the range of colors they can mix. On the chromaticity diagram, this means a larger area within the triangle. In the display industry, this triangle is what we call the color gamut. As display technology evolves, different gamut sizes have led to different standards, such as BT79, DCI-P3, and BT 2020. Currently, BT 2020 is the largest and most demanding standard, capable of displaying the widest spectrum of colors. Now that we've covered the basics of color gamut, let's get back to the TVs. How do we actually increase a TV's color gamut? As I mentioned, it's all about improving the purity of the three primaries. Achieving higher purity is actually quite straightforward. It is directly linked to the light source itself. Take the two technologies we mentioned, SQD-Mini LED and RGB-Mini LED. Both are essentially LCD-based TVs. Since LCD panels don't emit light on their own, they rely on a backlight. Light then passes through the screen's color filters to isolate the intended colors. To boost color purity, you must optimize either the backlight, the screen, or the quantum dots. This has led to two distinct technical paths: SQD-Mini LED and RGB-Mini LED. SQD-Mini LED focuses on optimizing the quantum dots and the screen itself. First, it uses advanced quantum dot materials to enhance the purity of the backlight. Then, it improves the filtering efficiency of the color filters to achieve pure red, green, and blue. The light path of SQD-Mini LED works like this. High purity blue light is emitted from blue LED chips, passes through super quantum dots, and is converted into high purity white light. After filtering through the subpixels, it results in a wider color gamut. Crucially, this entire process happens at the pixel level. This means the high color gamut remains constant regardless of the scene. Whether it's a simple single color image or a complex multicolored scene, the color gamut performance stays consistently at its peak. This is what all scenes wide color gamut truly means. RGB-Mini LED, however, tackles the problem via the backlight. When the screen needs to display a specific color, it only activates the corresponding colored backlight. This eliminates interference from the other two primaries. In these moments, the color gamut can reach very high levels. For example, when displaying a pure red screen, only the red LEDs are turned on. At this point, the red we see is incredibly saturated, naturally resulting in a higher gamut measurement. But if we switch to a complex, multicolored scene, which represents the vast majority of what we actually watch, the backlight zones will contain red, yellow, and white elements all at once. In those zones, red, green, and blue chips must all fire simultaneously to mix into white light. This light then passes through color filters to create the image. Compared to the single color test, the red becomes significantly washed out. This causes the actual color gamut to drop. In other words, RGB Mini LED is not a all scenes wide color gamut technology. The benefits of all scenes go even further. RGB Mini LED faces another prominent issue, color crosstalk. This leads to color instability and further sacrifices the gamut. For instance, on an RGB Mini LED TV, when displaying red and white side by side, the red area uses red backlight, while the white area must fire all RGB chips to create white light. At the boundary where they meet, the red and white backlights bleed into a pale pinkish hue. This makes the red look dull and the white appear reddish. Since the human eye is extremely sensitive to shifts in white, this is very easy to notice. This is the crosstalk phenomenon inherent in RGB Mini LED. While crosstalk can be mitigated, some current solutions involve simply forcing the backlight to output white light whenever a crosstalk risk is detected. While this hides the bleeding, however, it also causes larger areas of red to wash out, losing its original purity. Based on the technical analysis above, let's wrap it up. RGB Mini LED is undeniably a respectable technology. By changing the backlight composition, it boosts gamut numbers and creates highly saturated colors. However, it remains in an immature stage. Its peak gamut performance only applies to large areas of a single color. In real-world viewing scenarios, color instability and gamut loss are major drawbacks. This sacrifice in performance significantly devalues the RGB Mini LED's gamut rating, making it fall far short of the advertised 100% BT 2020. It almost defeats the entire purpose of the technology. In contrast, SQD Mini LED maintains its gamut regardless of the content. There is no compromise. What is advertised is exactly what the user gets. Furthermore, SQD Mini LED outperforms RGB Mini LED in other dimensions of picture quality. With the same number of LED chips and at similar cost, SQD Mini LED can offer at least 3 times the local dimming zones of RGB Mini LED. In terms of contrast, the core of picture quality, it delivers a massive upgrade. You get better depth and much finer detail in shadows and highlights. At the same cost, the brightness of each SQD Mini LED chip is also higher than that of RGB chips. This leads to higher peak brightness, more realistic highlight restoration, and better compatibility with high-spec HDR content. Across the holy trinity of picture quality, SQD Mini LED delivers a perfect score. Without a doubt, this is currently the best display technology for LCD TVs. So if you are looking for the ultimate visual experience, choosing an SQD Mini LED TV is absolutely the optimal choice right now. This cutting-edge flagship technology has been brought to the more accessible C8 and C7 series. If you want to experience the magic of SQD Mini LED, I believe the C8 and C7 series is the ultimate picture quality beast to get your hands on. Both SQD Mini LED and RGB Mini LED support 100% BT 1080 wide color gamut. But RGB Mini LED works well with single color visuals. It loses gamut and causes color crosstalk in regular multicolor scenes. SQD Mini LED offers true all scenes wide color gamut with better picture quality, dimming control, and brightness. To learn more about secrets of SQD Mini LED, stay tuned for more updates.